Hi, Chuck Huber here for the Stata YouTube channel. Today I'd like to show you how to fit a logistic regression model using a categorical predictor variable. I'm also going to show you how to test hypotheses about that predictor variable and how to estimate marginal predictions from the model and plot those predictions. I'm going to be using the NHANES2L dataset, and you can download this by typing webuse NHANES2L. And I'm going to be focusing on two variables in the dataset. First is our binary predictor variable high BP, which is an indicator for high blood pressure. And our predictor variable is healthstat, which is a categorical variable for health status. I've noticed here it has a value label named HLTH, so I've typed label list HLTH so I can see the categories of health status. So 1 indicates excellent health, 2 indicates very good, and so forth. Dot A is a missing category, and so it will be omitted from the model, so we don't need to worry about that. So let's begin by going to Statistics and going down to Binary Outcomes, and I'm going to select Logistic Regression. And for my dependent variable, I'm going to select high BP, which is here near the bottom. And then for my independent variables, I'm going to use this little 3-dot box here to select the independent variable. So I'm going to leave main effect selected, and then I'm going to scroll down to health stat right here. And I'm not going to check this box below C dot. C dot would tell Stata that health stat is a continuous predictor, and this is a categorical predictor, so I'm not going to check that box. And we're not going to be using any time series operators or mess with the base category for now. So then I'm going to click Add to var list to add this to my list of independent variables. And now I see that it's here in the list. So we'll talk about that I dot here in a moment. So I'm going to click OK. And this will fit our logistic regression model. So the dialog box issued the command logistic, so that's the command. High BP is our binary dependent variable. And then healthstat is our categorical predictor. Notice that the dialog box added an I dot in front of healthstat, and the I dot tells Stata explicitly that healthstat is a categorical predictor, and it will automatically create indicator variables for each of the categories for us. So if we look at the output, we see some model level statistics here at the top, the number of observations, a likelihood ratio chi-square and its p-value, a pseudo r-squared, and then in the output table, we see a list of odds ratios for each of the categories, along with their standard errors, z-statistics, p-values, and 95% confidence intervals. So health status is a categorical variable, and so we can see p-values for each of the specific categories, but if we wanted to test the null hypothesis that all of those odds ratios are equal to the null value of 1 simultaneously, we can type test parm, and then I.HLTH. Let me make sure I spell it correctly. And what that does is simultaneously test that each of the coefficients is equal to 0, or equivalently that the odds ratios are equal to 1. And so we see our omnibus chi-square test here at the bottom, along with a p-value for that chi-square test. Another thing that we can do is we can estimate marginal predictions from our model. So our output displays odds ratios, but if we go to Statistics and scroll almost all the way down where it says post-estimation, this opens the post-estimation selector, which allows us to do all kinds of things after we fit a model. We can do goodness of fit analysis, do predictions, and test things. And for now, I'm going to select marginal effects, estimated means, and interactions. So I'm going to click the plus to expand that. And we're just going to do some basic things for now. So I'm going to select basic and low dimensional analysis. So I'll select that and click launch. And that opens the margins dialog box. So here at the top in the main tab, I can select the kind of covariate that I want to consider. And so we have a categorical predictor. And that predictor or covariate is healthstat. So I'm going to select that here. And then I can select the analysis type, and there are lots of things I could do, elasticities, contrasts of marginal means. I'm just going to do sort of the basics, which is to estimate the marginal means of the outcomes for levels of the covariate. So that's kind of a basic marginal prediction. And then I'm going to click OK. And if I move this over, I can see the output here. So the dialog box issued the command margins followed by the name of the categorical predictor. And notice what this has created here is a table of marginal predicted probabilities. So what Stata has done here is converted or transformed the odds ratios back to probabilities. So what I see in the table is the predicted probability of high blood pressure for someone who has excellent health. So that would be about 31.3149148. For someone who's in poor health, the probability is higher. It's 0.57 if I were to round that. For each of these predicted probabilities of hypertension, I also get a standard error, a z-test, a p-value, as well as a 95% confidence interval. Now, one of the fun things I can do after I estimate marginal predicted probabilities is I can plot them. So if I go back to the post-estimation selector here, I can select profile plots after marginal analysis. So I'm going to click Launch, and this opens the Margins Plot dialog box. So in the main tab here, I'm going to select the variable that I want to define the x-axis. So that's the health stat variable. And let's just click Submit and see what that does. So that's going to create a profile plot for us. So the horizontal axis contains the categories of health status, and the vertical axis shows us the predicted probability of high blood pressure, high BP. And it's a profile plot because for each category it shows us a dot for the predicted probability of hypertension, along with a 95% confidence interval around that prediction. And we see that for each category, and then the categories are connected by lines. So that would be a profile plot. Some people prefer bar charts. Some people call these plunger plots or dynamite plunger plots. I can change my plot by going to the Plot tab and selecting bar. And then when I click Submit, this converts that to a bar chart. Now, I like to put a little gap in between the bars because this is a bar chart, not a histogram. And so if I click on, I did that kind of quickly. If I click on bar properties and come down here to bar width, I can type 0.9 and accept, and that will add a little gap in between each of the bars to emphasize that this is a bar chart and not a histogram. Now, and it also displays a 95% confidence interval for each of those predicted probabilities. Now, some people prefer to see these displayed horizontally, so we can go back to the main tab and check this box that says swap the X and Y axes, make a horizontal graph, so it's going to transpose our graph for us, so that now the predicted probability appears on the the X-axis, and the categories of health status appear on the vertical axis. And if you wanted to, you could also convert this to a scatter plot. So if I go back over here to the Plot tab, I could change this to a scatter plot and click Submit, and that would display this as a simple scatter plot with the 95% confidence intervals. One little trick that I like to do is to add a little space at the top and bottom. So if you go to the Overall tab and click Region Properties, and then Plot Region, here at the top, I usually do large. So if you select a large gap for the plot region and click Submit, that adds a little bit of space at the top and the bottom, so it looks a little bit more natural. Okay, so let me show you a fun trick you can do after you do all of this stuff. I'm going to close these dialog boxes and come over here to the History window, and I'm going to right-click on any command and then select All. So that selects all of them, and then I'm going to right-click again and select Send Selected to Do File Editor. And what that will do is send all of those commands that were generated by the dialog boxes to a Do File Editor. And I can save this file and then run it over and over again, so I can reproduce my analyses anytime I want. It also shows me all of these options for the various commands that I use, so I can learn the option names for those and maybe type these next time rather than using the dialog boxes. Okay, so that's how I can fit a logistic regression model with a categorical predictor variable, test some hypotheses, estimate some marginal predictions, and then make some plots. I hope this was helpful. Thanks for stopping by.